Hi friends, see let us start vectors part 2 now. In part 1 we studied about parallelogram law of vectors. That means when two vectors are making some angle with tail to tail angle theta, the resultant is got by root over a square plus b square plus 2ab cos theta. Now in this part 2 vectors we will be dealing about dot product of two vectors applications, cross product of two vectors applications, and one or two numerical problems. Okay, so let us start now. So dot product of vectors. Now how to define dot product of vectors here? For example, two vectors are there, a bar and b bar. Suppose two vectors are there, a bar and b bar. If theta is the angle between them, then dot product states that a bar dot b bar is equal to a bar modulus b bar into cosine angle between them. That means, see here, that means b vector along a vector, that is the component of b vector along a vector, that is nothing but magnitude of the vectors a bar b bar and the cosine angle between them. So finally you will get a b cos theta. This is equal to a bar dot b. So you can see here, b cos theta is the component along a vector. So this is a dot b. In the same way, you can define b dot a. Okay, that is, this is a vector, this is b vector, angle theta. Now we have gone in before a dot b. Now b dot a. So b dot a means draw perpendicular a on b, then you will get the component of a vector along b. Therefore, mod b mod a into cos theta, or modulus of b ఎంత అవుతుంది, b modulus of a ఎంత అవుతుంది, a. So ba cos theta. ఇక్కడ చూడండి, a cos theta is the component along b vector. A cos theta is the component. Therefore, this is given by b dot a. So you can observe a phenomenon here. A dot b, 3 into 2, 6. Okay, 3 into 2, 2 into 3, same. So it is obeying a property called as commutative property. Again, it is obeying commutative property in dot product of vector. That means a dot b is equal to b dot a. Very, very important. In the same way, it also obeys distributive property. It also obeys distributive property. What is distributive property? A bar dot b plus c is equal to a bar dot b bar plus a bar dot c bar. So it also obeys distributive property. That means a dot b plus c is equal to a dot b plus a dot c. So this is how we will be explaining the dot product of two vectors. Okay. Right. So just now we defined the dot product of two vectors. So after learning about dot product of two vectors, what are the applications? So generally applications are in intermediate. If you see IPE, 4 marks question, application means that is potential energy. Potential energy, that is P is equal to mgh. Okay, that means, for example, a body is resting on the ground, W is equal to mg. Suppose this body is raised to a height h from the ground level, for example, say h w, and we all know weight is a vector quantity. So work done, in other words, work done, that is potential energy, is given by force into displacement. Force into displacement means height vector. Therefore W means mg into h. So this is the first application for the dot product of two vectors, that is potential energy. And also you can also take work done. Work done also you can take, okay, because work is a scalar quantity. Force dot displacement, that is Fs cos theta. This is second application. Third application you can take it as power. Power is nothing but rate of doing work, W by T. And what is work again? F dot S by T. And what is S by T? Rate of displacement, velocity. Therefore, power you can write as F dot V. Another important formula. Okay. So the dot product of force and velocity is again power. That is, you can say that force is a vector, velocity is a vector. Dot product, it is a power. The same way, work done. Okay. Same way, work done. So like this, you can applicate the dot product of two vectors. Okay. So these are the main applications. Now we will try to solve a small numerical by using dot product of two vectors. For example, note down this problem, all of you. For example, say a force of 2I plus 3J plus K newtons acts on a body of mass 5 kgs, say. Okay. Suppose this body is displaced to, for example, say I cap plus 2j cap plus k cap meters. For example, this body is displaced to a displacement of I cap plus 2 j cap plus k cap. Then what is work done? Work done is given by F dot S. Okay, given by F dot S. So here 2I plus 3j plus k dot S. I plus 2j plus k. So this is how you have to do work done. But here, when you are doing this one, you should know the properties of dot product of vectors. What are the properties here? You can see from the question itself, we can derive properties. See, as you know, I dot I is equal to 1. The same way, J dot J is equal to 1. J dot J is equal to 1. The same way, K dot K is equal to 1, unit vectors. And if you go like this, I dot J, again 0. J dot K, vector 0. K dot I, 0. This is how you got, For example, these are the axes, X, Y and Z. Along x-axis we know I vector, y-axis J vector, z-axis K vector. These are the unit vectors along the X, Y, Z. So if you consider I, J, K as the unit vectors, then the properties of dot product goes as I dot I is equal to 1, J dot J is equal to, because I dot I means y, it is 1, same direction, cos 0 is equal to 1. Okay, if they are perpendicular, cos 90 is 0. Therefore, that is why I dot J is equal to 0, J dot K is equal to 0 and K dot. Even if you go in reverse order also, because cos of minus theta is cos theta. Even if you go in reverse order, cos of minus theta is equal to cos theta from trigonometry. Therefore, in whichever notation you go, either you go like this direction, or in reverse direction, clockwise or anti-clockwise, the value will be same. Okay, because cos of minus theta is cos theta. So therefore, same dot product, that is I dot I, J dot J, K dot value is 1. And if you go with I, J, K, the opposite one, the perpendicular values, the value will be 0 because cos 90 is equal to 0. So if you apply this property here and solve, what is I dot I? 1. 1 into 2, 2. I dot J, 0. I dot K, 0. You can come into second one. J dot I, 0. J dot J, 1. 1 into 2, 2. 2 into 3, 6. Again J dot K, 0. K dot I, 0. K dot J, 0. K dot K, 1. 1 into 1, 1. So what was the value? 8 plus 1, 9 joules. So this is the work done by the force is equal to 9 joules. So this is how we will be solving by using dot product of two vectors. So at a time the properties are completed and the numerical is also over. Please note down. Now, after learning about dot product of two vectors and applications, let us go to the cross product of vectors. Okay, let us go for cross product of vectors. Cross product of two vectors. So how to define cross product of vectors? Suppose A bar and B bar are two vectors. Suppose A bar and B bar are two vectors. If theta is the angle between them, then the resultant of these two vectors is shown by the third vector C bar, which is also perpendicular to the plane containing these two vectors. If A bar and B bar two vectors, this is the third vector. And this can be explained by two rules. Either right hand corkscrew rule, either it can be explained by right hand corkscrew rule. Right hand corkscrew rule, or you can even explain by using your right hand curl rule. You can also use by right hand curl rule. Right hand curl rule. So I will tell you how to apply the right hand curl rule or screw rule. Screw rule, how to apply? See, this is A vector and B vector. Now you are finding cross product of A cross B. So when you are doing A, this vector is perpendicular to the two vectors A bar and B, making 90 degrees. So A cross B is given by mod A, this is unit vector n cap along the C vector, mod A, mod B into sin theta into n cap, where n cap is a unit vector along the direction of the two vectors AB. So AB sin theta into n cap unit vector 1. So A cross B, the value is given by AB sin theta, or I will write once again, A cross B is equal to AB sin theta, equation 1. That means, how to explain? By using either right hand curl rule or screw rule. Suppose you apply screw rule. Imagine that the screw is tightened. So which is going in the direction of A cross B. Because when it is going A to B, it is A cross B. Again now loosen, unscrew. Then the screw is coming back. So then which you can see? This is A vector and this is B vector, and theta is the angle. Then this will be the resultant now. C vector is equal to B cross A. Because B cross A. Now you are unscrewing, you can see. Same thing I can explain easy method by using right hand curl rule. See, how to go use right hand curl rule is, suppose A cross B, put your fingers along A and turn along B. So A cross B, see, the thumb is indicating along your direction. So this is the resultant vector. See, A cross B, thumb is indicating like this. So this is the resultant coming into the outside the board. So this resultant is coming outside the board. In the same way, B cross you can see. Put your four fingers, B, and curl along C. You can see, B cross C. Thumb is coming downward direction. So this is the resultant. Okay. So this is how you will be using the right hand curl rule. That means A cross B means put your four fingers along A and curl along B. The thumb is indicating the direction outside the board. In the same way, B cross A means put your four fingers along B and curl like this along. So coming downward direction. So in this way, A cross B and B cross A. So the value is got by like this. B cross A is given by mod B, mod A into sin theta into n cap. So same, but here the direction will be different. For example, this theta is equal to positive in this direction. If you take theta is positive here, and here if theta is equal to negative, then what happens? Sin of minus theta is minus sin theta from trigonometry. Therefore, what happens here? B A, here for example, if you write sin of minus theta, so that is minus sin theta, minus AB sin theta. That is equal to B cross A. So you can observe here, this is equation 2. Equation 1, A cross B is AB sin theta. Equation 2, minus AB sin theta. This implies that A cross B is not equal to B cross A. So it does not obey commutative property. It does not obey commutative property, because sin of minus theta is minus sin theta. Like it's not like cos. Cos of minus theta is cos theta, but sin of minus theta is minus sin theta. Therefore, it is not obeying commutative property. Okay, so now just now I defined what is cross product of two vectors and also dot product of two vectors. Now let us go for application of cross product. In application of cross products here, in applications of cross product, we have so many applications. Number one, relation between V, R and omega, relation between linear velocity, radius vector and angular velocity, that is V is equal to R omega. Okay, that is the first application. Second one, you can also apply for angular momentum. L is equal to mvr, is also vector. Okay, that means angular momentum is equal to mv means momentum, p and r. So this I can also express as r cross p, angular momentum. This is the second application. Okay, angular momentum is equal to mvr, linear velocity v r omega. And also you can apply in the second year physics, you will be having moving charges magnetism. There you have F is equal to QVB sin theta. So here also you can apply the cross product, that is force is equal to charge into velocity cross magnetic field induction. So this is also application. F is equal to QVB sin theta. F is equal to charge into V cross B. Here V is velocity of the electron, B is magnetic field intensity, magnetic field induction. So like this you can apply the cross product in different cases. In the finding out the derivation of V is equal to R omega, angular momentum R cross P, and also F is equal to QB sin theta. Okay, right. Right then. So these are the main applications. Now let us see the properties of cross product. So cross product properties, if you go, just like dot product is also having some properties. For example, this is x, y, z, I cap, j cap, k cap. So these are the unit vectors along x direction, y direction, k direction, that is z direction. That means this also can be represented in simple technique I, j, k. I cross j, j cross k, k cross. If this is taken as positive, for example, this is taken as positive clockwise, then anti-clockwise you can take it as negative. That means against this direction, like this, coming like this or going like this direction. This is anti-clockwise. This is taken as negative. So here you can observe I cross I. Apply the formula I mod I sin theta. So I cross I means along x-axis, same direction. What is same direction? Theta, 0. So sin 0 is 0. Therefore, I cross I is equal to 0. In the same fashion, j cross j, same direction, angle 0. Therefore, j cross j, 0. The same way k vector cross unit vector is equal to again 0. Because why you are taking 0 here? The vectors are along the same direction. Same direction means whatever, the angle is 0. Sin 0 is 0. Okay? This is all. Now we will go to the I cross j. See here. I cross j. Clockwise. Clockwise taken as positive. So I cross j means mod I, mod j, sin. What is the angle between these two vectors? 90 degrees. So sin 90. And which is the vector perpendicular to these two vectors? I cross j, k. So k cap. So 1 into 1, unit vector magnitude is 1 into sin 91 into k cap. So what is the value? I cross j is equal to k cap. In same way you can go for j cross k. J cross k. Its value will be what? Clockwise. I. The same way k cross I. K cross I. Clockwise. J. See, this is one direction. Suppose if you go in reverse anti-clockwise, I cross j, ila I cross j kaakunda, j cross I will be anti-clockwise. Appudu em avutundi value? If you go in reverse, if I go like this, j cross I, then what I told you, anti-clockwise taken as negative. So sign of minus that again minus. So therefore this becomes minus k cap. The same way here, j cross k, reverse, k cross I, j cross I, k cross I. So k cross j. This is minus I cap. The same here. I cross k. K cross I clockwise. I cross k anti-clockwise. So what is the value? Minus j cap. These values, formulas are very, very important regarding the properties of cross product. If you remember this, you can apply this circle and easily you can find out the values for numericals. So very, very important properties, please note down. Now, this cross product of vectors can be also represented in another form, very easy method. That is, even you can go like this, or in mathematics you will be having a determinant form. In determinant form also you can express. See how I will write it in that form. For example, see, A vector is given by 2i cap plus 3j cap plus 4k cap. And let B vector is given by minus I minus 2j plus 3k cap. So suppose these two vectors are given for you and he is asking you find A cross B. Then the easy method in determinant is draw two lines. First write the unit vectors I, j and k. Now how you are going A cross B or B cross A? A cross B means first write the A elements with the sign convention. A elements means 2. What is the value along j? 3, 4. Next B. What is the value here? Sign convention. Minus 1. Okay. A cross B. Minus 1, minus 2 and here 3. Now how to calculate first one? I cap into, first to remove these elements. Now what elements left are? 3 3s are 9 minus AB minus CD, just like matrices. Okay. 3 3s are 9 minus of minus 8. Minus of minus 8. So this is the value. Second one will be minus again according to the properties of determinants, cofactor minor. So minus j cap into, again remove these elements now. Now what are left out? 3 to the 6 minus of minus 4. Okay. Now this last element is again plus k cap into, now remove these elements. So minus 4 minus of minus 3. Now the thing is over. I cap into 9 minus into minus plus 9 plus 8, how much? 17. 9, 10, 17. Minus j cap into minus plus 6 plus 4, 10. Plus k into minus into minus plus, that is plus 3 minus 4. How much? Minus 1. Plus 3 minus 4 minus 1. Now finally the answer is 17 I cap minus 10 j cap minus k cap. This is the result of A cross B. Suppose if I ask you B cross A, then first you have to write here B elements. First you have to write B elements and then down A elements. So this is how you can find out by using determinant method. You can directly apply your properties, or by using determinant method in mathematics, you can calculate the value of A cross B. Clear? Please note down. Okay, 1, 2, 3, right. Now, by using cross product and dot product, you have solved some numericals. Now, one more thing in this one is, in cross product and dot product, the most important thing in intermediate, little extended syllabus this is, how to find out the area of a triangle, area of a parallelogram, and volume of a parallelepiped. These are the last three topics in this vectors chapter. Okay, these are the last topics in the vectors chapter. Okay, let us see now how to find area of triangle. So we all know from geometry, this is a triangle. For example, A, B, C. And this is, altitude, height. Let this height be, for example, say H. Let this height be H. Okay. Now let this vector be A bar. I told you tail to tail, not from head to tail. So this is one vector. Let us take this another vector B bar. Now let the angle between them is theta. Now how to get area of triangle? We all know area is given by half base into height. Okay. So area is equal to half base. Base means here what vector is there? A vector into height. So h. How to calculate this h here? So here you can see from trigonometry, this is theta. Opposite by hypotenuse. See here. Opposite by hypotenuse. Opposite by hypotenuse is equal to sine theta from trigonometry. Or h is equal to ఏమైంది ఇక్కడ b bar sin theta గా రాయొచ్చు. సో ఈ ప్లేస్ లో హైట్ ప్లేస్ లో ఏం చేయొచ్చు మనం సింపుల్ గా you can write as b bar sin theta. Now observe this function here. What is this one? A is equal to 1 by 2 into, if you observe carefully, this is nothing but again what? Cross product. A cross B. Therefore, area of triangle you can write it as half of A cross B. Half of A cross B. This is how again you can calculate the area of triangle. If any numerical is given, A vector value is given, B vector value is given, A cross B find out by using determinant method and divide by 2. You will get area of triangle. Okay? Note down please. Right? Okay. So this is how you will find out the area of triangle. Now next one, how to find area of parallelogram again by using vector notation. See how to find area of parallelogram. See here area of parallelogram. So we all know this is a parallelogram. Okay, that is a parallelogram. You know the properties also, opposite sides will be equal just like rectangle. So I will name some letters A, B, C, D. This is a parallelogram. Opposite sides are equal. For example, I will take one vector A bar, another vector as B bar, and the angle be theta. Now how to get area here? See, area of a parallelogram is given by area of a parallelogram is given by same here. See, I will extend this one like this. So simply if you get area of parallelogram, I can write directly like this, A cross B. I can directly write as A cross B. What is A cross B? See here, mod A, mod B into sin theta area, or A is equal to mod A, B sin theta. That means it is nothing but A cross B. A cross B. That means directly you can see from here, you can understand one point. What was area of a triangle? Half base into height. See here, area of triangle is equal to half base A cross B. Half base into, but here how much you got? AB sin theta. Here half AB sin theta. You got it here as half AB sin theta. That means if you multiply this one with 2 times, you will get area of triangle. That means area of parallelogram is nothing but 2 times the area of triangle. Okay? So you can see here, if you multiply with the 2 will cancel. This is nothing but area of this thing, parallelogram. That means area of parallelogram is nothing but 2 times. Area of a parallelogram is nothing but 2 times the area of a triangle. Okay? Area of parallelogram, that is A cross B, is equal to 2 times area of triangle. If you multiply the 2, AB sin theta, you will get AB sin theta. Okay? How you got that one? You can see here. This is the height. This is height here. Okay? So height. How to get height here? Angle theta here. This is theta and this is theta. So how to get height here? Opposite by hypotenuse. This is A vector and this is B vector. This is A vector and that is B vector, not here. This is A vector and this is B vector. How to get height from this triangle? Opposite by hypotenuse, that is H by B from your trigonometry, sin theta. Therefore, what is H? B sin theta. So how I got H height of the parallelogram? B sin theta. So AB sin theta is nothing but from this triangle got B sin theta. Therefore, this is the component B sin theta of the other side of the parallelogram, adjacent side. Therefore, parallelogram area is nothing but 2 times the area of a triangle. Okay, that's it. Let us go to the last topic in this one. last one, that is volume of a parallelopiped. Volume of a parallelopiped. This is the last point. After that, I think one thing is left over, that also I will complete, and then we will end up the chapter. Last one, that is volume of a parallelopiped. See, how to get volume of a parallelopiped. Now, do you know what is meant by parallelopiped? Very easy. See, suppose this is a rectangle, I mean solid rectangle, 3-dimensional. This is a rectangle, solid rectangle. Now suppose if this rectangle is bent little, shear, then it becomes parallel. I will show the diagram, see. I will draw here. I will draw here this side. How to get parallelopiped. Clear? See here. See? If you bend little rectangle towards keeping base constant, you bend like this, shear. This is a parallelopiped. This is parallelopiped. Parallelopiped. So here you can see this is the base area. For example, this is A. Length you can take as L. Breadth you can take it as B. And this you can take it as height H. Okay? And also in vector notation also you can give like this. This is A vector. Okay, this is the thing, no? A vector. A vector and this one. Okay. This is the length of the thing here. See, this is length, breadth and height. How you will get volume of any rectangle, I mean solid rectangle or parallelopiped? Volume is got by area of the base into height. How will get the volume of this parallelopiped? Area of this base area, that is this base area, that is A into B into height. See, A means here length, no? You have taken as L, B and H. So area of the base means how much? Area means L into B. This is area of base into height. So this is your volume of the parallelopiped. But in vector notation, how you will give? In vector notation, I will show you now. So 6 here now, this point is there. Right, just now discussing about parallelopiped. Now just now what I told parallelopiped, what is meant parallelopiped? For example, you take a solid rectangle, keeping the base, if you literally shear it, small shear force, it will bend into a solid parallelogram. The solid parallelogram is called as a parallelopiped. How you will get the volume? For example, L is the length, B is the breadth and H is the height. Volume means LBD. But in vector form, how you will express? See here. This is the base area, you can see base. The hatchet portion is called as base area. So here you can see this is the A vector along the base, A vector. And this is B vector. This is A vector, this is B vector, and this is C vector. A, B and C. So how to get here? So volume is nothing but base area, that is A cross B, base area, okay, this is base area into height. Base area into height. So how to get base area? Just now I told you the curl rule. A cross B. See here. Put your fingers, 4 fingers like this. A cross B. Cross your fingers along B vector. A cross B. Okay? A cross B. You can see this side. So this or A cross B. Like. See, anyhow you can apply like this or like this. But here A you are taking like this, so A cross B. So this thumb indicating the vector direction. Okay? This direction or this direction. So this is the resultant vector. A cross B resultant is showing in this direction, you can see. A cross B resultant is showing this direction. But along this direction, what is height? How to get this height? See here. Adjacent by hypotenuse. Adjacent by hypotenuse, C vector, is equal to what? Cos theta. See here. Adjacent by hypotenuse, cos theta. So therefore height is equal to how much here? C cos theta. When you will get C cos theta? When you are taking dot product. Therefore, A cross B dot C vector. This is called as volume of parallelepiped. Have you understand the point here? See here, we are finding the cross product. We have to use screw rule, or you can use the curl rule, either screw rule or curl rule. In curl rule, curl along the direction A cross B or B cross C. So A cross B, A cross B, A cross B. So your thumb is indicating an upward direction. So this is the resultant vector. But this vector is how much? It is perpendicular. So how to get this height? Adjacent by hypotenuse. C vector is like this. So adjacent by hypotenuse is how much? Adjacent by hypotenuse cos theta. So C cos theta. H by C is equal to cos theta, or H is equal to C cos theta. But C cos theta is nothing but what? Dot product of two vectors. Therefore, A cross B dot C. This is also called as scalar triple product. Dinne scalar triple product of vectors అని అంటారు. Otherwise, it is also called as scalar triple product of vectors, or otherwise simply you can call it as box ABC. Box ABC. Now I'll explain what is this box ABC. See here. Now let us see what is this box ABC. See, box ABC means, what is box ABC? See, you can express in different forms box ABC in scalar triple product. See here. Box ABC I can write as first method A cross B dot C. Next, B cross C. What will come next term? A. C cross A. What will be the term here? B vector. So box ABC you can verify in any way, you will get the same value. If you do A cross B dot C, value. B cross C dot A, value. C cross A dot B. In three ways, whatever way, box ABC, the value will be same. The value will be same. So this is how the volume of a parallelepiped can be calculated. This is also called as scalar triple product of vectors. Simply in mathematics you will be calling as box ABC. A cross B dot C. B cross C dot A. C cross A dot B. Clear? Okay, then in the vector part 2, actually what happened is, due to overlook, I think I forgot to tell a small point. That will be the last topic in vector part 2 and also in vectors. That is subtraction of vectors. Actually I forgot that one. So I am telling in the last part of this vectors part 2. Okay, please make a note here. So what is meant by, we already know what is the addition of vectors, A bar plus B bar or B bar plus A bar. But how you will define subtraction of vectors? See, there is no perfect definition for subtraction. Subtraction of vectors is nothing but addition of two vectors with proper sign. For example, you can see on the board, there are two vectors, A bar and B bar. So here subtraction means you can see, this is A vector, this is B vector. Then where you will get a negative vector B here? The opposite side, you can see. If I take the image here, the opposite side here. So this will be minus B bar. So negative, how you will add vectors means, for example, A bar plus B bar, you know, adding of two vectors. Subtraction means what? See here, A bar plus minus B bar. That means adding two vectors with their proper sign convention, whether it is a positive vector or negative vector. Here A plus B means A plus minus B. That means what happens? A bar plus into minus A minus B. So like this, again you can see here, this is A vector. See here, this is A vector and this is B vector. What is the other side of A vector? Minus A. So here you can see minus A this side, B and A. This is one vector, this is another vector. You have to come like so, this will be a resultant. So what is the resultant here? B bar plus minus A bar. Leda దీన్ని ఎలా రాయొచ్చు? B bar plus into minus ఏమవుతుంది? Minus. So B bar minus A. That means there is no direct subtraction here. There is no direct 2 minus 3 or 3 minus 2. Subtraction of two vectors means adding two vectors with proper sign convention. Clear? Right. Now last point in this one. last point. For example, see in the above figure, see here, two vectors are given. For example, here you can observe here, two vectors. As I told you in the beginning, how to express the angle between two vectors, always with tail and tail, not with head and tail. But the fellow has given here, see here, this is one vector and this is another vector. Suppose in the examination got like this is theta. So this is wrong expression, this is wrong method. So how to express, I told you the properties, you can extend the vectors parallelly. So what you will do, how to express the theta is, I will extend this one, I will draw here, it's better so that you can understand. Same thing I will draw here, this is the wrong expression. What is the correct one? See here, this is one vector, A bar, and this is another vector, B bar. Now in the examination they are given for you angle theta like this. So to correct it, what will I will extend this vector. I told you just now I can parallel shift. So now this is the vector here, A bar. Now see, here is given theta. Now what will be this angle? What is the total angle? 180. So 180 minus theta. So this angle becomes 180 minus theta. So here this is A vector and this is other side of vector A. This is other side. So this is 180 minus theta. Now the vector angle, see, this is one vector, this is another vector. So these two resultant you can find out now. This is one vector, the resultant is like this, in this direction. Resultant. I will get by using your parallelogram law. Root over A square plus B square